An angle is formed by rotating a ray about its endpoint. So if this is the endpoint of my ray, we form an angle by rotating this ray. So now it's right here. So this is my angle. I'll say it's 30 degrees. So that is how you form an angle. This is the initial side, and this is the terminal side of your angle. This represents the start position and your end position. The end position is your terminal side. This point right here, the end point of your ray, this is called your vertex. This is the vertex of your angle. Standard position is when your initial side is on the x-axis. So I'm going to make this my x-axis. This is where we're always going to start. That is your standard position. From your standard position, you can either go this way and form an angle. That would form a positive angle, or you can go this way and form an angle. This is clockwise. This would form a negative angle. This is negative 30 degrees. Okay, so counterclockwise will form a positive angle. Clockwise will form a negative angle. Okay, let's talk about coterminal angles. Coterminal angles are angles that have the same initial and terminal sides. So for example, let's take that same example. This is my initial side. This is my terminal side. This is a 30-degree angle. Now, if I rotated 360 degrees and landed right back on the same spot, I am now at 390 degrees. How did I get 390 degrees? Yes, it's the original angle, which is 30 degrees, plus doing a full circle, which is what? Yep, 360, so 360 degrees. So 360 degrees plus 30 is 390 degrees. So guys, notice these angles are in the same position. So this is called a coterminal angle. They share the same terminal side. Now, this is my positive coterminal angle. I can also rotate. I can also go this way and land at the same spot. So I'm going to do 30 degrees and I'm going to go clockwise. So this will be negative 360 degrees. And what will this end up as? Negative 330 degrees. So guys, these are terminal and coterminal angles. The coterminal angles for 30 degrees are both 390 and negative 330. They share the same terminal. Okay, now that we talked about all of these, let's talk about radians. This is how you measure a circle. So a full circle is 2 pi radians. A full circle can also be 360 degrees. A full circle is also called 1 revolution. So these are the 3 different ways to represent the distance around the circle or the angle of a circle. These are the 3 different measurements that we're going to use, okay? We're going to convert between these 3 different ways. So 360 degrees is the same as 2 pi radians, which is the same thing as 1 revolution. We're going to be converting between these 3 different things. So let me show you an example. Let's say I have a angle right here at 45 degrees. And I want to change that to radians. So if I want to go 45 degrees and I want to change it to radians, what I'm going to do is multiply by 1. I'm going to multiply by 1. And the way I'm going to do that is I'm going to multiply this by 2 pi over 360 degrees. Isn't this just 1? Because it's the same thing. 2 pi is the same thing as 360. So anything divided by itself is just 1. Notice what will happen. First of all, can we simplify this? Let's divide this by 2 and get what? Yep, it's just pi. And divide this by 2 and get what? 180. So let's just multiply by this. Okay, so let's just multiply across. I'll get 45 pi over 180. Let's simplify this further. We can divide this by what? 45, good, and divide the bottom by 45. So I'm going to get pi over 4 radians. So we went from degrees to radians. Let's do another example. Let's say I have this angle right here. What degree is this? It's a 90-degree angle. So 90 degrees, let's turn it into radians. I'm going to multiply by pi over 180. This is equal to pi over what? 2. And it makes sense because let me show you. From here all the way around is what? 2 pi. That means from here to here is just pi, right? And well, this is just half of that. That's pi over 2. Okay, so we went from degrees to radians. Okay, now let's go from radian to a degree. We'll do the same thing. Now let's say I have pi. Let's say pi over 3. Now let's change this to a degree. Pi over 3, this is in radians. Let's change it to a degree. I'm going to multiply by 180 over pi this time. Those pi's cancel. What's 180 over 3? 60 degrees? Perfect. So guys, your goal in this is just basically to cancel out. Here, I have degrees and I want to cancel out degrees. Here, I have radians. I want to cancel out radians. Okay, let's try to do revolutions. So guys, in the same way, let's try another one. Let's say I have 90 degrees. Let's figure out how many revolutions this is. You're always going to multiply by a ratio. So I want to figure out what the revolutions are. How many revolutions? Well, guys, 1 revolution is the same as what in degrees? 360 degrees. Okay? Well, degrees will cancel with degrees. So what's 90 times 1 is 90 over 360. Those cancel. We can divide the numerator and the denominator by what? 9. So we get 1 over 4 revolutions, which makes sense if you think about it. This is 90, 180, 270, 360. So a 90 degree is 1/4 of a revolution. Okay, let's try it again. Let's try another one. Let's say I give you 270 degrees. Let's do that. My goal is to get it into revolutions. How many revolutions? What do I put down here? 360 degrees equals 1 revolution. Your degrees cancel out. 270 over 360, so I get 27 over 36 revolutions. And let's simplify this. Yep, divide both by 9. 3/4 revolutions. And that makes sense because when you think about a circle, this is 90 degrees, 180, 270, 360. So that was 3/4. This, and this is 3/4 of a revolution. Okay, so I'm going to pause here. I want you guys to do on your paper. I want you guys to convert 60 degrees to radians. I want you guys also to convert 7 pi over 2 to revolutions. How many revolutions is this? How many times is this around the circle? I'm going to give you guys a moment. All right, look up and see if you got it. So to go from 60 degrees, that means I need to put degrees on the bottom. If I'm starting with degrees, degrees will go on the bottom, and I want radians. So what should I put here if I want radians? 2 pi radians. Oh, some of you guys probably simplified this. Raise your hand if you did it this way, pi over 180, because these are the same thing. Okay, perfect. We'll do it that way. All right, so we're just going to multiply across. Degrees cancels with degrees. Perfect. I get 6 pi over 18, which can be simplified further. Divide them both by 6. You should get pi over 3. Did everyone get that? Perfect. All right, for number 2, we're going to revolutions. So I'm going to do 7 pi over 2. I'm starting in radians. That means radians needs to go in the denominator, because that's what I'm starting with, radians. My goal is to get to revolutions, so I'm going to put revolutions on the top. 1 revolution is the same as 2 pi. That's my ratio. Okay, now we just multiply across. Those pi's cancel. 7 times 1 is 7. 2 times 2 is 4. So you should get 7/4 revolutions. One thing to point out, guys, whenever you're working in degrees, you're always going to have this little degree symbol. When you're working in radians, you won't have anything. You could write radians, but you don't have to do that. It's just going to be a pure number. Pi, which is 3.14, and so on, divided by 3. If you put this in your calculator, you'd get an actual number, okay? Whenever it's in radians, you're not going to see radians spelled out, okay? However, if it's in degrees, you will know it's in degrees because it will have a degree symbol. For revolutions, it will not just be a simple number. It'll say 7/4 revolutions. Do not drop this unit. Because if you just put 7/4, I'm going to assume that's a radian. Okay? Radians are the only ones that doesn't have anything attached to the end. Okay, so don't drop the units. For revolutions, you should always have REV, indicating how many revolutions you're doing around the circle. Another example, let's say I'm going from radians. This is radians. And I'm going to go to revolutions. Remember, whenever you're in radians, you don't have a unit. It's just the number 1. So the same way, I'm going to say, since I'm in radians, radians will go in the denominator. And 1 revolution is equal to 2 radians. So this is my answer. 1 over 2 pi revolutions. If I have 1 radian and I want to go to degree, then this will be hello, pi over, or 180 degrees over pi, which is just 180 over pi. So this is your answer in degrees. This was in radians.